Alright, so we're going to be working with parallelograms today. We're going to be proving and applying theorems about them, and this is just the first day. So learning goals. I can describe the properties of parallelograms and apply those in a proof, and use the properties of the vertices of a parallelogram to solve for missing angles. Alright, so let's start with the properties of parallelograms. So we'll talk about their sides first. With the parallelogram, the opposite sides are congruent, which means that this side is congruent to this side, and this side is congruent to this side. It doesn't necessarily mean that all four of the sides are congruent to each other, just that the opposite ones are parallel. So like, if this one was 10 and this is a parallelogram, then this would be 10. If this was 5, then this would be 5. Also, the opposite sides are parallel, so that means that these two sides are parallel to each other, and these two sides are parallel to each other. Alright, so as far as angles go, the opposite angles are congruent. So this angle is congruent to this angle is congruent to this angle. The other thing is that consecutive angles are supplementary. So meaning if I took these two angles, they would equal 180 degrees. If I took these two angles, they'd equal 180 degrees, and so on and so forth all the way around. So if you go to one angle right after the other, they're 180, opposite each other, they're congruent. All right, some vocabulary to know. We've got a parallelogram, which is a four-sided polygon, also called a quadrilateral, with opposite sides parallel and congruent. So CP/CTC is a theorem that can be used after two figures are proven congruent in order to show some or all of the remaining parts of the figures are congruent. So let's say I had a parallelogram. Let's make it easier on ourselves. Let's say I had a triangle. Alright, two of them actually. And I proved that the two triangles were congruent by side, angle, side. If I use CP/CTC, I could then say, well, now this angle is congruent to this angle is congruent to this angle, and this remaining side is congruent to that remaining side. If that's something that would help me, I could use that. And then definition of congruent line segments is just line segments that are equal in length. Alright, so we need to complete the following proof, and we need to fill in the missing pieces. So that would be right here in number 2 and here in number 4. So we're given that quadrilateral LMNP is a parallelogram, and we need to prove that LQ equals NQ and PQ equals MQ. So we start off with our given, as always, that this is a parallelogram. And then we need to fill in this blank, and the reason that we're given is the definition of a parallelogram. So the question is, what would that be? So usually what I would suggest doing when you have these fill in the blank proofs is go ahead and look at the next one, and it says when two parallel lines are intersected by a transversal. Now, there's nothing in here yet that says anything about parallel lines. So therefore, if you go back, let's say we went back to here, we're told that opposite sides of a parallelogram are parallel. So we can go forward now, and we'll say that LM is parallel to PN, and LP is parallel to NM. And that is by the definition of a parallelogram. Then you can go through and say that these angles are congruent because alternate interior angles are congruent. Now we have to find a reason for LM being congruent to PN. And that's because opposite sides of a parallelogram are congruent. So we're going back to, again, the definition of a parallelogram. And then the rest of it's filled in for you. But we would, basically what's going on is we prove that triangle PNQ, so this triangle here, is congruent to MLQ. And then prove those congruent by angle, side angle, and then use CP/CTC to show that parts are congruent, which gives you your proof. Alright, so now we know that ABCD is a parallelogram. If CDA, so that is this angle right here, is 66 degrees, then the measure of BCD, so this angle here, is what? Again, diagram might not be to scale. So angle BCD and angle CDA are consecutive angles. Remember, they come right after another, which means that they're supplementary. Remember that characteristic of a parallelogram. So if we took the two angles and added them together, we'd get 180. We do know the measure of angle CDA, which is 66. So what we have to do to find angle BCD is subtract that from 180. which gives us 114, and that should be degrees, 114 degrees. So that's it. Normally you have 3 examples. This one back here would have actually been, this would have been one part right here, a question, and this would have been a question here. So there were 3 examples. It's just that 2 were built into 1. So that's it. One more target for this particular key concept, and we're done, and more than halfway through the semester. So you guys have a good one. Thank you.